Hi guys, I'm out today as you know. You do have a test tomorrow over section 10.1 in the book. I'm going to quickly cruise through the notes that we did the last couple days. And then I'm going to go through that you try it problem that I gave you in, I think it was a blue cutout. Not all of you glued it in, some of you did. Does preschool help? This is a confidence interval. To study the long-term effects of preschool programs for poor children. If you remember, we looked at kids who attended preschool and kids who didn't, and we looked at the proportion of them who needed social services as an adult versus the ones who didn't attend preschool and needed social services as an adult. If you look over here, P1, we labeled the kids who attended preschool and needed social services. P2 were the kids who didn't attend preschool and needed social services. The first part of the state plan due, for state, we label our parameters. If you cruise down here, next, we looked at this, and this is a little bit of a pain. The plan part, see, I'll put a little. The method is below. The method is how many samples do we have? 2. The poor kids from preschool, the poor kids who didn't go to preschool. What are we doing? A Z or a T? We're doing a Z, zap, tax. We're looking for an interval for the difference of the true proportion of kids who went to preschool and needed social services versus the kids who didn't go to preschool and needed social services. We're going to assume randomness, which is right here. And you almost need a little highlighter. Assume randomness. The two populations are independent. Just remember that I needs 3 of them. Our sample size, and again, I'm cruising through this. And then our normal condition. Remember, the independence condition is so we can use that standard deviation. The normal condition is so we can use the Z table to find percentages, and that does work for confidence intervals as well. Our do part, what I want for the do part is I want at the very least all of this. Let me highlight it. So what do I have here? I have p hat of 1 minus p hat of 2 plus or minus 1.96. Where did that come from? That came from my Z table, excuse me, it actually came from my T table where you see infinity and the confidence level at 95%, 1.96 is right above it. And then we have our standard deviation. This part right here is from page 5. Okay, here's the actual formula you see on page 5. Okay, and you plug it all in, and then you just run a 2 proportion Z interval in your calculator where you have your X1 here, your N1, your X2, your N2, and your confidence, and that's where this pops out. Now, if the question asks, do we have significant evidence that it's different based off the confidence level, make sure you have 3 things. You would say, yes, here we have significant evidence that there is a difference between poor kids who attend preschool and poor kids who don't attend preschool who need social services later in life, because you need to say our 95% confidence interval does not contain 0. If you miss the 95% part, you will be docked. And you just then need to say it in context. We're 95%, yes, we have significant evidence that there is a difference and it helps to attend preschool. Why? Because our 95% confidence interval does not contain 0. The actual conclusion, though, that I'm looking for in the state plan do conclude, what I just previously talked about was that partner problem you had earlier, and I gave a lot of you guys feedback on that part. But the actual conclude part here is that I am 95% confident that the true difference in the proportion of poor kids from Michigan who went to pre-K versus didn't go to pre-K and needed social services is between negative 0.3474 and negative 0.03. So that's an interval I just cruised through in 5 minutes. Listen to it slower, listen to it again if you need to. Otherwise, there's all other videos that I did not make over this you can watch. Next, we did a 2 proportion Z test. That's what we went through today. I'm going to cruise through it fast, and then there's one you can try at the end. A two-sample z-test for P1 minus P2. You're going to want to pause right here if you were gone yesterday and just get these notes down. These are just different ways that you can write your alternative hypotheses. After you pause and write all this down, the next one you're going to need is the formula for P pooled or P combined. You only use this during a test. Notice you do not find a common denominator. You just add across from P hat of 1 to P hat of 2, the numerators and the denominators. Next, we're talking about the high levels of cholesterol and blood are associated with higher risks of heart attacks. There's a study that takes gemfibrozil and compares it to people who took a placebo. They then, after 5 years, look at men in both groups and the proportion of them who had heart attacks. For our null hypotheses, we always assume they are the same. P of G is equal to P of P. In the state step, I do want the parameters labeled right here. Okay? P of gemfibrozil is the proportion of all middle-aged men, like the volunteers, who had a heart attack and took gemfibrozil. The P of placebo group. Now note, it's the proportion of all middle-aged men, like the volunteers, who had a heart attack and took no drug. I don't say placebo because the whole population's not taking a placebo. The placebo was only for control in the study, but those people are representing people who don't take any drugs. Then what are we trying to prove in the alternative hypothesis? We're trying to prove that the proportion of men who took the gemfibrozil and had a heart attack is less than the ones who didn't. There's our state part. Pause our state part if you need more help. Ask someone next to you or shoot me an email on that part. The plan step is the same as our interval. The only thing that is different is the two-sample z test for P of G minus P of P. Pause and look over it. If you have any questions, again, write it down, email it to me, or ask someone in the room. Just note that this is my P hat of 1. This is my P hat of 2. Okay? Placebo group here with my cursor. Gemfibrozil group here. Again, please note that normally we use our P, but we're not given a true parameter here. We're only given a statistic. The only true parameter that we know is that we're going to assume they're the same, and that's what happens in our third step in our do part. In our do part, pause it right now and write down all of the things that I'm expecting in the do part, and then I'll talk through it. Once you've paused it and written down all of those things that I'm expecting, let's talk through it. Our picture, we have our curve right here. You see the center is always assuming that the difference between them is 0. The standard deviation now is the tough one, okay? You need to look at page 5. In page 5, you will see for 2 samples for a proportion, there's 2 different standard deviations in the box. The top one is for the interval. The bottom one is for a test. You'll see P of 1 equals P of 2. And below it, you'll see the square root, which we have here, of P times 1 minus P. Here's my P. Here's my 1 minus P. Whoops. Where does that come from? That comes from my P combined or my P pooled. So I took my statistics, I added across the numerator, and I got my P combined. And that then goes right here. And then I multiply it by 1 over N1, my first sample, plus 1 over N2, my second sample. And I take the square root and multiply them. I don't have to do that work. The calculator will do all of that work for me. What I do next then is I take my statistics here and subtract them. Now I'm going to plug this all in my calculator at this point. So let's back up here. What have I done so far? All I've done so far are the things that I've highlighted, right? And it looks messy. I'm sorry, forgive me, and use the notes from someone else as you need, if you need. But I drew my picture that I just highlighted. I put my center down. I'll do it in pink now. Okay, which is right here. That's 0. I did my standard deviation that I got from finding my p combined. And I plugged everything in. And how did I know how to plug it in? I looked at my formula sheet on page 5. Before I actually plugged it in the calculator, I believe, it doesn't really matter, but I am going to mark p hat of g minus p hat of p. Well, why did I do that? I should be expecting that it's less than. Now you might want to double check that or just put it in the calculator. If you're a little confused, just go right to your calculator right now. You're going to a 2-prop z test. On that 2-prop z test, you are going to take x1, which is right here, n1 right here, x2 right here, n2 right here. You're going to do your hypothesis. Your hypothesis is a less than, I believe. So that's the middle button, if I'm right. And then you're going to calculate. When you calculate, you'll get your p hat of g, your p hat of p. Okay? So pause it right now if you need to type it all in. Hit enter. You should see these numbers in your calculator. You don't even need to subtract those. You just know that this is my statistic, the difference of them. We know a z-score is our observation, our observed statistic, so that's right here. Minus our mean. It's always going to be 0 in a test. Divided by our standard deviation. We already plugged everything in. And the calculator gave us z is equal to negative 2.47. A p-value of 0.0068. What does that mean? Well, because our p-value is approximately 0.0068, which is less than alpha of 0.05, we reject the null hypothesis. We have evidence that the proportion of people like these volunteers who have had heart attacks and take gemfibrozil is less than the proportion of people like the volunteers who have heart attacks and take nothing. Pause it, rewatch something if you need, and now I'm going to get to the new stuff. A 2-sample z-test for P1 minus P2. The first thing I need you to do in the General Motors problem is please cross off this number and please cross off this number and fill those numbers in with 20% and 10%. I want you at this moment to pause it and try the problem on your own if you need some extra help or just want some extra study time. I'm not going to have everything down, but I'll talk through what you need. Once you're done, hit play and listen to the rest, check your work. The state part, your P of F, I wanted a subscript, I couldn't do it in this computer. The proportion of all people like the ones at this company who quit smoking based on financial rewards. P of T, the proportion of all people like the ones at this company who quit smoking based on traditional methods. Hopefully you have that down. Next, my null hypothesis. I'm going to assume they're the same, always. And I want, in this case, the proportion of people who quit smoking for financial rewards to be greater than the traditional method. Why do I want that? Because it says, does this result of the study give convincing evidence that the financial incentive helps people quit smoking? So that proportion should be greater if it helps them. The plan step. The plan step I didn't do totally, just know random. Okay, was there a random assignment? It was most likely volunteers, so that's what you state, just like we did in the beginning. The independence, make sure you state that the two are independent of each other, and then check your 10N is greater than or equal to capital N, which would be all people who smoke and get financial incentives versus all people who smoke or are trying to quit smoking based off the traditional methods. Check with a partner, email me, take a picture of it, send me if you have questions. And then why did I put the p hat here of F and the p hat of traditional? Well, I put that because you're going to need that for your n step, your normal step when you're rinning. So you're going to do the n times p hat because we don't have a p. So n times p hat has to be greater than or equal to 10, and n times 1 minus p hat has to be greater than or equal to 10. And there's your p hats for the financial rewards right there versus the traditional. The do step, okay, what are you going to need? You are going to need a picture, okay? In the center, you're going to need 0. Do you have that? The difference in your statistics is 0.1. So that's going to be on the right-hand side of the 0, and you're going to shade to the right. You're also going to need your standard deviation. Your standard deviation is with your p combined or your p pooled. Here's your p combined, 90 over 450. How did I get that? I had to take 450. It's not letting me write very well. 450 times 0.2, which gives me 90. So that's my x1 here. And then how did I know it's 450? N1? If you read, it's 900 volunteers, I believe, and they split them in half. So that's how I know the N1 is 450 and the N2 is 450. And then how do I know it's 45 for the second group? Well, they said 10% of them stopped smoking, so that would be 45 out of 450. I add across the numerators and the denominators. This is an error. I'm sorry. This should be 900. But this is not an error, 0.15. That's my p combined. Why do I need my p combined? I need it for my standard deviation. So you have your z-score now, your 0.2 minus 0.1 subtracted from 0 divided by my standard deviation using p combined. Remember that p combined, that standard deviation here, is equal to the square root of my p combined times 1 minus p combined. This whole thing then is being multiplied by the square root of 1 over n1 plus 1 over n2. You don't need to actually calculate it. You just need to plug it in. And then your calculator will do everything for you. And you'll find that your z-score is 4.2 with a p-value of approximately 0. And you can then conclude. Because our p-value is approximately 0, which is less than alpha of 0.05, we reject the null hypothesis. We have evidence to believe that the proportion of people like these employees who quit smoking because of financial incentives is higher than the proportion of people like these employees who quit smoking because of traditional methods. Finally, I just think it's important to remember, what is a p-value? It's the probability of getting a statistic as extreme or more extreme than the one we calculated, given the proportion of people who stop smoking because of financial rewards and the proportion of people who stop smoking because of traditional methods is the same. All right, that was a haul. You may have listened to all of it or just a short piece of it. Write down your questions, please. Let me know what you need help with. And here again is a list of things that you need to do. So we did a partner problem on Thursday. Friday we had notes. Here was your new homework. We have a partner problem today, and you do have a test tomorrow. Please note that this homework is due as well, okay? So this is the homework that goes with our Friday notes. If you have any questions, shoot me an email. I will be checking my email. Thanks, guys.